students. All right. So I did this last year, second semester. I would make help videos, but looks like I didn't make help videos in YouTube for first semester. So here we go. I'll hope they help. Quiz 103. They will not be every single question, but your questions will be similar enough that the steps that we use, the thought process, the logic, should benefit. Woo woo, look at you guys go. If you're in 7 or 6, remember you get all 3 attempts. So please try those. Please reach out to me. I want you guys to succeed and feel comfortable and confident in your math skills. And the best way to do that is just by trying and just continuing to try, okay? All right, here we go. We'll just start with this one. Which ordered pair is the solution to the system of equations? So some vocabulary words there. Ordered pair, right? That's that parenthesis, x, comma, y, and it has to do with the relationship on a coordinate plane. X coordinate, y coordinate. It tells you how far over and how far up or down or left or right, right? That's what they're asking you to find. Y equals 1/3 x minus 6. When I see that, I think I'm going to use substitution method. Now you guys can use the graph. If at any time you want to just go graph these, yes, do it. Technology is the best, saves us time, does some thinking for us, but we have to check it. We have to make sure it's right. I'm going to use substitution method so that you guys see algebraic ways of solving, and then I will also show you on the graph because it's pretty quick. X plus 3y equals -12. Because y is already isolated, meaning on one side of the equal sign, I'm going to substitute the y into the top equation. See, there's y, this whole thing is going in there. 1/3 x. What a nice question, right? You guys see that? It's such a nice little question that they did for us. Don't forget the equal sign, which sometimes I often do. Then I confuse myself. Right, 3 times 1/3 x. So we'll have x over here plus distributive property 3 times 1/3. Well, they're inverses of each other. They're reciprocals of each other. They undo each other. 3/3 is just 1. So that becomes 1. It's very nice of this problem is what I'm saying. And then 3 times -6, -18 is equal to -12 plus 18. Like, oh, you didn't combine like terms. Oh, well, I got in the flow and this is what I saw. So I'll do it in one step. These two will now become 2x because I'm combining like terms. I added 18 to both sides to get rid of it. It cancels, but in this case, it equals 0, and we don't need to write zeros. That's what they mean by canceling. It will either equal 0 when we're talking in terms of addition and subtraction, or it'll equal 1 when we're talking in terms of multiplication and division. It's called the identity property. -12 plus 18, positive 6. Okay, 2 times x, get in that flow. If it's multiplication, we divide. You're welcome to use a calculator, and but you'll see this again cancels. Remember, that becomes 1. 2 divided by 2 is 1. X equals 6 divided by 2, so x equals 3. That's just the first step. We need the ordered pair, so we know we have x. All right, let's go find y. Well, look, let's just plug it in there. Look how nice they are again. That's pretty nice of them. All right, up here, y equals 1/3 times x, but we're saying x is 3, so you replace the 3, just minus, sorry, 6. So you have 1/3 times 3, that's just 1, friends, and you're welcome to use a calculator. 1 minus 6, again, calculator for negative work. Keep thinking about how the relationship works, but that should be -5. So we have 3, -5, close parenthesis, we have our ordered pair. Boom. All right, what about this nifty graphing method like I told you? I'm going to highlight the whole thing because that's just what I do. I know how to switch it when I get there. Oh boy. I zoomed in. So I'm going to paste the whole thing. Oh, never mind. The copy paste didn't work. Look at them. That was an email. Control copy. Check your email. Always a good idea. Control V. There we go. So this one looks fine. It ended at -12. This one, I'll hit Control X, which is the cut function. That's not right. Why? This didn't copy the fraction. So whatever language they used on the other website didn't transfer to Desmos. So I'll make it a fraction. Oh, it didn't work. It's 1/3. Arrow over. Get rid of that 1/3. come click on this dot, 3, 3, -5, we're done. Took a little bit of technology. You could just have typed it, clicked back and forth and been like x plus 3y equals to -12. You don't even have to put it into slope-intercept form. And you could have typed y equals 1/3 x. Notice how if you do that, you still have to make sure the x is next to it, not in the denominator, -6. So you could have typed it. You don't have to copy paste it. There you go. Moving on. Oops, we're going to get rid of these questions. Question 2, variation 2. Again, you might not have the same variation, but the same skills will work. Woohoo! Okay, so this one wanted to test a couple of things. If you look closely over there, they lined up the x, they lined up the y, they lined up the answer or the constant. But they didn't. What they lined up was the variables, yes, but they didn't line up the symbols, the equal sign. So if you're going to use linear combination method, you need to make sure that both variables are on one side of the equal sign or the same side of the equal sign that you're going to combine. Because technically, if we brought the y over there, we would be fine. But what I mean is we can't subtract this and change the equal sign to a subtraction sign. That doesn't work. Okay, so they were kind of being tricky there. So you could use, so in this case, I would still use substitution method. If you don't want to use substitution method, you could bring this y over there. And that actually might be faster, so let's try it. I'm going to subtract y from both sides to get my equation in standard form where both variables on the left and the answers on the right. So then I'll have my top equation will remain the same. Remember, you can fast forward through these videos as well. You can pause them as well. We'll have x minus y is now equal to 4. Yes, so this is actually pretty quick. Either one, if you plug in x over here, you'd get 4 plus 2y, so then y should equal, I was trying to be fast, 1, -1. Oh, anyway, let's just do this. So let's combine these. X is going to be 10, so I just add the entire thing. Some of you have asked, how do you know you're going to add it? Well, in this case, I'm going to add because the signs for the variables I'm trying to remove are opposites. So I can just combine them. So I'll get 2x. Oh, x, it's going to be 5. This goes away, plus y minus y. It cancels. It actually just equals 0. It just means no matter what y is, if you add that, and then whatever it is, you then subtract that, it'll be 0. 6 plus 4 is 10. Divide, x is equal to 5. At this point, you can just check to see if solutions are there, and if there's only one x equals 5, you're done. You're done. Then you can just substitute it in. If x equals 5, right, so 5 equals y plus 4. Oops. Let me subtract 4 from both sides. I get 1 equals y. Aha, my mental math was right. Boom. Remember, this is an ordered pair. It's always x first, then y. If ever you forget, just sing the alphabet. A, B, C, D, E, F, G, X, Y, and then Z. Sometimes Z, X, Y, Z. But it's in that order notationally. Okay. Question 3, variation 3. What is the solution to the system of equations using the linear combination method? Okay. Well, here we go. They're very nice to us. I'll write it over here. The top equation plus y equals to 2. It's already in standard form. The variables are on the same side of the equal sign, the left-hand side, which is aesthetically pleasing, I guess. It doesn't matter as long as you're careful. That's a wonky parenthesis, but it's a parenthesis nonetheless. We're going to subtract. How did you know to subtract? Take a look. I'm going to get rid of the y's. Why the y's? Well, because they match. We have a regular y up the top and a regular y on the bottom. Their coefficients are the same. So if I subtract the bottom one from the top one, something quite nice will happen. Remember, though, you're subtracting each term, even across the equal sign. -4x. So 5x minus 4x is regular x. That's so nice. That's that one. Then we're going to take away y. Y minus y is just 0. We don't even need to write it. And then 2 minus 5, you still have to do that, -3. Okay, so now once you have the linear combination method, you get one variable by itself. You just pick an equation. I'm just going to pick the top one. You substitute it in, and then you solve for your missing variable. That's -15 plus y equals to 2. We add 15, so y should be 17. 2 plus 15. Y should be 17. There you go. Question 4, almost done. Calculator. What is the solution to the system of equations? You know what? They didn't give you a method. Let's just copy paste it. What do you think about that? There's no fractions. They'll paste on the same line, but I know that this one, Control X, Control V. I'm a big believer in technology if you haven't noticed. So even those little shortcuts of all the shortcuts you guys find out there, use them. Time efficiency, 5, -2. 5, -2. All right. So some things to talk about here, this concept of what is a solution. It's the point they intersect. Now, it's very likely that you could end up in a situation where we now look, there's the black line, then the blue line. The black line, the blue line, but they're not the same. It's 40 and 30 and all this stuff. Correct, right? Now it looks even more different, but it's still the same line. So in this case, it's infinitely many solutions. In this system of equations, these two equations actually are the same line. They just look different. And I mean, there's so many different ways that they could look. Let's say this is going to be y is equal to, let's see, 12 thirds x minus that did not work, did it? Here we go. Let's just do this. You're like, this is the perfect time to fast forward, by the way. Oh, silly. Here we go. Oh. Well, anyway, as you can see, it's going to look, you can do lots of different ways to get the lines to be exact. It didn't work, my method, so I'm going to move on for right now. It was impromptu, but those are infinitely many solutions. So what about no solutions? Here we go. This one has no solutions. Between the blue and the black, they will never intersect. They are parallel. Okay, so they are parallel lines and they have no solution. No solution, no solution, no solution. All right, sorry about that. You'll see me get distracted a lot because, again, I genuinely love mathematics and thinking about mathematics and playing with mathematics. I don't actually really like students. I just wanted to do math all day. I'm just kidding. Just kidding. I love being a teacher. It's my, I look forward to it all of the time. Oh, this is a slider. This was, if you guys weren't in class, I have to show you this. All right, let's go ahead and, well, this is a situation where it would actually make more sense to do it one at a time. So I'm going to copy each row. This is from my student in class. What a cool idea to use Desmos, because Desmos doesn't graph in 3D, and this is a three-dimensional system. It has 3 variables. So you can think of it as height, like if you think of height and width, or length and width, now you can think of height. So 3 dimensions. Okay. Add a slider. So this is what they did. And they put them into Desmos and they just made a slider for Z, add a slider, right? And they slid it until they all 3 intersected. Then when you click on it, you can see Z is going to be -3, X is 5, and Y is -2. Remember X, Y always, and then Z. So you look for that and you'd be done. We're going to solve it algebraically. 5, -2, -3. 5, -2, -3. X, Y, Z. All right, let's focus. So if we're going to solve this algebraically, one of the things that we did in class was linear combination method. Now, while I still think it's a good idea to use that method because it prepares you for the future if you pursue mathematics, and if you're solving complex systems like this, your odds are you're going to want to practice those skills and you're interested enough that you're going to take it again in college. But we are all about efficiency, and this was a very kind thing that they did to us. They gave us an equation that was already missing a variable. That leaves us the opportunity to use substitution method in a system of 3 equations. So I'm going to solve for Z. In this case, this to me would be the logical, more efficient method, right? So now we have Z is equal to 12 minus 3x, right? Now I'm going to take that and substitute it into both of the remaining equations, because then I'll have x and y only. I will have replaced the z with just basically x. Okay, so here we go. The top equation will be x plus 3y minus z, so minus 12 minus 3x equal to 2. The middle equation, I'll come down a little bit, will be 4x plus 2y plus 5z equal to 1. No. 12 minus 3x equal to 1. Okay. It may look really scary and complicated, but all I did was use the proper, substitute it in. I was just careful. I made a mistake, but checked it, fixed it. And now I'm just going to take all of the skills we've ever used and just slowly use them, just piece by piece until it's nice and familiar. Up here, the distributive property, right? And I can change colors. So now we're going to start using the distributive property to solve this. -12. I'm going to do some work right here. So this will become -12. This will become positive 3x, right? Because I'm distributing that through here. So now I know I'm going to have x plus 3x. So I'll have 4x. Okay, I just combined like terms. You need to distribute the negative first so you have the correct combining of like terms. 4x plus 3y minus 12 is equal to 2. Let's go ahead and just add that 12 to both sides. Right, so that way I'll have 4x, and we'll come over here, 4x plus 3y is equal to 14. And remember, I added to both sides because it was minus 12. All right. So let's do the same thing here. Let's distribute. We'll get 5 times 12, which is 60, and you can use a calculator, and 5 times -3, which is -15x. So I just did a little bit of work right here, and then I'm going to combine. So why signs matter. 4x minus 15x is actually going to be -11x plus 2y plus 60 equal to 1. Okay, so let's subtract 60 from both sides. Did I do anything wrong? I don't know. We'll find out, right? Follow along, check my work. We're a team. What did I miss? 4, 5, 15, 12. Looks good. All right, here we go. I just don't like that number. That's why I'm doing this. All right, so now we have negative 11x plus 2y is equal to negative 59. We can go check our work. That's what I'm doing right now. So get rid of all of these. Since I already know the answer, 4x plus 3y, I'm checking my algebra is what I'm trying to do right now. So if I did this part correctly, I should get the same numbers, and I don't. Yeah, see? I'm going to pause the video and check my work. Never mind, it's fine. The numbers are not pretty, but it was completely fine when I went to go check my work instead of trusting my algebra. I forgot to put the negative here, but notice we have a 5 and a negative 2, so we're good. Let's keep going. Algebraically, haha! All right, friends, okay. So over here, let me make sure we're recording. Yep, we're good. The numbers were just ugly, so I wanted to take a second and check my work, and I couldn't see anything I did wrong, and I was like, okay, well, how come the graph is wrong? Well, I entered it wrong. Now I don't know. Let's what do you guys want to do? Right? What do we want to do to solve this part? Okay. So I think we should just use linear combination. I'm going to multiply the top by 2. I'm going to multiply the bottom by negative 3. So I'm going to get rid of the y's. So this will become negative 6, and this will become positive 6 when I'm done. 2 times 4x is 8x plus 6y equal to 28. Negative 3 times negative 11 is positive 33. I, like you, also don't like negative numbers unless they're useful to me. Negative 6y equal to. So just a quick thing about number fluidity, number sense. 3 times 60 is 180, but 59 is 1 less. So it should be 177. So you can check it, and then a negative times a negative becomes a positive. So 177. Does that kind of make sense? Just again, it's very important to play with these ideas and be comfortable playing with numbers. That'll be 180. Therefore, if you multiply 3 times 59, well, 59 is 1 less than 60, so it would be 177. All right, anyway, so now let's combine them. We will have 41x. See, these are ugly numbers, and whenever they're like kind of odd numbers, I get suspicious that I'm doing something wrong because math books have trained me to look for pretty numbers. So don't be like me. Trust yourself. Look at that. That's 5. Oh, haha. Okay, so now we're going to divide both sides by 41. It'll be okay. And eventually, when you do that, 205 divided by 41 gets you x equal to 5. Now we're cooking. We can now solve the rest. So we have x equal to 5. We'll have 20. I just substituted it in here. 4 times 5 plus 3y equal to 14 becomes 3y. We're subtracting 20 from both sides equals negative 6, which means y divided by 3, negative 2. Okay, if you've made it to this point in the video, we have 5, we have negative 2. We can then use 5 right here. And actually, we just needed 5 to find z. Oh, even better, you could have just used that equation. All right, anyway, we would have 15 plus z is equal to 12. Therefore, z is equal to negative 3. Oh boy, lots of fun. Math is fun. Struggle is fun. Never think it's always supposed to be easy. Be okay making mistakes, confusing yourselves, checking your work, asking for help. Hope these are useful tools to you. Hope they are useful videos. I know it's not maybe your exact problem. If it is, congratulations. But again, you've got to do the thinking. I'm going to try to get quicker and more pointed as I make these each time. Okay? Again, thank you for watching.